Hey everyone, this is Code Metaphor. So, in the last video, what we talked about is a class and the idea of an object. Okay, one thing I want to say is if you don't imagine, you have to have an imagination about your object. Okay, everything for a computer is not how we see it, and that's the power of programming, where we convert our imagination into code and the computer understands it. Okay, now. And the class is a sketch. Okay, I'm developing something. I'm creating I'm building a house or something. I first make a sketch of it, right? I first draw it. I first see the constraints and everything. And let's suppose here will be my car. The color will be like this. It will have this. It will have the wheels. It will have the front end, the back, and any other detail. The seating color, and the functionalities within it. So that will be my sketch. And once I produce that car, once I say, okay, now here is the object, here is a real object, a real car that you can drive. That's my object. I instantiated a class, okay, an object also. So, um, so as I said that it's my own. What makes it easier for me is I tell myself like, okay, it's just bunch of variables together, a combination of pointer. So for example, I have let's suppose student name equals to uh, let's suppose AB, let's suppose mm, code metaphor. Okay, and then ID is equal to 12 and then there is something else. Um, I can say subject is equal to chemistry. This is an object. The problem is it's not together. These are independent units. Okay, for Python they are an object, but for us they're not. Okay, so what we're gonna do is, first of all, jump to our topic of linked list. We're gonna code a linked list, and you will see how easy it is to create an object. And this is nothing smart about that. Okay, so I'm gonna write class and a class. So we have two objects in linked list. One is the linked list object, the other one is the node object. Okay, which are the individual nodes of a linked list, which is A, B, C, or 1, 2, 3, or anything, or let's suppose New York, California, Chicago, if we know these addresses, or you have friends, or you know somebody, he knows somebody, he knows another person, he knows another person, stuff like that. Okay, now I can write class node. This give us that box. That's it. You have a sketch of a class. It's that easy in a computer. You don't have to actually draw it even. Okay, now here is my more part of a draw. This is a constructor in Python, init function. Okay, this is an init method in Python, and then this word self. What what are our attributes? What are you gonna give it? We're gonna give it a data, right? Now I will write self. I'm gonna explain self. Self.data is equal to data. Okay, and then I'm gonna have another thing. Self.next. Next is equal to none. That's it. There you go. You have an object created, right? The self keyword allows you, just think in this term, this allows you to access these instance variables, right? To access data and to access the next. If we don't put it, the class, the object can, any other object or the object cannot access these variables. Okay, now I can initiate this object. I can say, let's suppose node underscore 1 is equal. This is how you initiate an object. Node, you see automatically Python is picking from the constructor that I need data. Self is not. Self is nothing. Okay, self is just a word in Python where it tells it about its own attributes. Okay, now I'm gonna say 5,000, right? That's it. See what happened? Nothing happened, right? This object is now in production. It's ready for us. If I print it, if I say print node 1, you see what happens. Node object at this memory location, right? Now if I want to see the data of this node, I'm going to say node 1 dot data. See what happened? Boom, it's giving me 5,000, right? If I say node 1 dot next, well, it's going to give me none because there is nothing in front of it, right? Now I can print another node. Node 2 is equal to node, suppose I can say 6,000, and then what I can say, I can set its next pointer of this node to this node. So I can say node 1 dot next, because we have access to it, is equal to node 2, right? And now do nothing. We can say what is print node 1 dot next. You see previously it was none, right now it's a different node. What if I say node 1 dot next dot data? What's gonna come? You see 6,000, because node 1 dot next is pointing to the node 2 whose value is 6,000, so next dot data is 6,000, right? So that is the idea here. Let's remove this. Now here we have a node. We have that box, that node, you call it that we have the car right now. Okay, we have the node. And then we have the two attributes, data and next. And now we have another class linked list. Okay, that's it. Linked list is ready. And then define init, and it's just gonna take self. You're not gonna give it anything, and then we will have self dot head is equal to what? Is equal to none, because it's empty right now. Boom, we have a linked list. You see how easy it is? Imagine that in the previous video how much stuff we draw, and to tell computer those two things, this is how it looks like for a computer. Compiler takes this, does the back end magic, and boom, the computer understands a linked list. Okay, now our linked list class, we are giving it functionality. This is an independent unit right now. Here we will have functionality, like let's suppose adding at the front of the list. Okay, so we'll have a function define add at front. Let's add something at the front. So self, and then what are we gonna give? Let's suppose I'm giving it name it anything, my value. Name it my value. Okay, that's it. This is it. And now what are you going to do with the my value? Okay, so the moment you call, the moment you call on this linked list, you make a linked list. The moment you call this function on it, say linked list dot add to the front, just like a mathematical function, dot add to the front this value. This value entered this value right now is not a node, it's just a value. So what's going to happen? We must call here this class to give me an object node. You see how logical it is? So I'm going to say my node is equal to, I'm going to call the node class and ask the node class, hey, give me an instance. And he's going to say, what's the data? And I'm going to say, well, the data is my value. You see, the data is my value. Boom, I have a node called my node, and it's ready. The node is ready. Now what are we going to do? Now remember, we had two cases. One is if the head is still none, or if the head is not none, because it's possible that the linked list might have some other elements and we are adding to the front. But first we're going to check if self.head is none. Okay, this is one thing. if self.head is none. We are saying C if self.head is none means that the linked list doesn't have anything. Then what are we going to do? Nothing. We are going to do self.head equals to, we are accessing this variable, this pointer, this characteristic, this attribute of the linked list class, making it equal to my node. That's it. We are done with one case. Okay. Else, what are we going to do? What's the else part? Think about it right now. If it's not the case, then what are we going to do? If it's not the case, then the node dot my node, the my node dot next will point to self.head, because self is already pointing to some element, and I want to say that my node dot next means that this my node, this next is right now none, because we just created this node, right? When we created this, it looks like a box having a data which is my value. Let's suppose it's 6, and the next is none. I'm saying now if this one fails, code is going to come down to the else part, and my node dot next equals to self.head. Because self.head is pointing to the other node, I'm asking it now you point to that node. Okay, and then self.head is equal to my node, right? My node is pointing to that node, and self.head is pointing to my node. So then we have a chain, right? So that is it with this function. Let's see it. What are you going to do? The value will come in. We will make a node of that value, of course, because this is just a value. I'm adding it to the linked list, and I know a linked list has a node. We got a node. What is this node? What does it has? It has the data part, which is my value. It can be any value, 1000, 1,000,000, 156, a string, anything. And then the next part is none. Of course, we just made this node for another one. You can instantiate millions of them. Doesn't matter. It's up to you. Okay. Then we came here and said, hey, we have two cases. If self.head is none, it means that linked list is empty. Self.head is still none means linked list is empty. It's not pointing to anything. There is nothing, right? Then point self.head to my node is going to be h arrow to a. Let's suppose h arrow to a is our node. Else, if that's not the case, and this is not none, means that there are nodes in here. So I want you to my node dot next equals to self.head, because self.head is pointing that node. It means we are pointing to that node right now, and I want self.head to not point that node and point to my node. And that's it. Our function is ready. Okay. So this is one function. Define. We are going to have another function adding to the back. Okay, now we will have addition to the back of the linked list. Add to back. Okay, now self my value, right? And what are we going to do with my value, right? We're going to make a node just like before. This is where we get confused. My node is equal to node. What is it going to get? My value. That's it. We have access to a node right now, right? We have access to a node. Now, what we're going to do? The same two cases. The two cases. I'm adding to the back. There is a possibility there is no back. Head is empty. So I'm always going to say if self.head is none. Okay, if self.head is none, I'm just copy and pasting that. Then self.head is equal to my node, right? Else, if that's not the case, then I have to, I'm adding to the end, right? And we have, let's suppose h is pointing to a, to b, to c, and then there is null, right? Let's imagine. Let me put a comment here. This is our head. It's pointing to a is pointing to b, b is pointing to c, and C is pointing to none, right? Now we will start from A, see if the next is none. If it's not none, we're gonna move the pointer to B, see if its next is none. Na, move the none. Its next is none, so we know this is our node, this is the end. We have to figure out, the computer doesn't know anything. We have to figure out where is the end of the list. Where is something? Whenever something is none, we know its next pointer is empty. Okay, so now I'm gonna make a temp variable that will point to self dot head. Why? Because I know self dot head, which means A, this is self dot head. Okay, I know you are confused a little bit that hey, this is head. Yeah, because head is pointing to this. This you can consider this as head, or this can be considered as A also. Okay, so temp is equal to self dot head. We have a pointer standing right now here, just my mouse pointer. We are here at A. So after that, if your pointer is here, what are you gonna do? Okay, now you have to make a condition. In here I'm saying if temp dot next, because I know temp is pointing to A, this is like a copy of A. Just imagine that temp and A are now similar things, but I'm making a copy so I don't lose A, right? Now if temp dot next is not none, then I want you to move the temp to B, right? Now see, I'm gonna, because we are doing it for everything multiple times, so that's an indication we will use while loop. I'm gonna say while temp dot next is while temp dot next is not none, I want you what? While temp dot next is not none, what do I want you? Then I want you to move the temp pointer to the next node, which means temp will now be equal to what? Temp will be equal, because in here temp is at A while the condition is checked. When it's not none, what we are going to do is we are going to say that temp is equal to temp dot next. You see, now you will understand also self dot head. This is temp dot next because temp is here, the temp dot next is this one. Now temp is equal to temp dot next. Okay, and if that's not the condition, so it's gonna come here, yeah, it's not none. It's gonna come here, it's not none. When it's here, when this while loop runs, this condition is checked, the next one is none. So we know we need to get out of this while loop. In here, what I want to do is I want to, because this is temp right now, I know it's none, so I'm gonna say temp dot next equals to what? Equals to this my node. Okay, that's it. You see, we have the node class, we have the linked list class, we have the constructor for the linked list, we have the added front, added back methods for the linked list. Okay, now what we're going to do is also go to initiate. Now let's make a linked list. I'm gonna call it my linked list is equal to, see, linked list. I'm calling, entering nothing. I got a linked list, it's ready. This is now my linked list object, right? I just initiated it, my linked list object. You want to see? You see, I'm gonna say my linked list, this is my object. You see here, linked list object at this index. And now I say what is the dot head of this linked list, my linked list. Okay, so my linked list is equal to linked list and dot head. Okay, linked list self dot head. Okay, my linked list. Now dot self, let's see if we can get this attribute self print my linked list at head. Okay, we're gonna come back to that. I'm gonna see why can we not access the head. Head is equal to none. Okay, oh yeah, we have a problem, and I'm really amazed why it didn't give me an error. So okay, I have an object. We should be able to access the head. Yeah, you see none, because I forgot a double underscore in the constructor in here. Okay. So we have a linked list that starts from none. Okay, and now what I can say is I can say my linked list, right? My linked list do what? I want to ask it function that you have. My linked list, call your function, add at front. What do I add at front? The function tells you, give me my value. I want to add at front 1. That's it, right? Then I can copy this and paste it here and say my linked list add me 2. Then I can say my linked list add me 3. Okay, but there is also one thing we cannot just say print linked list. It's not gonna print, it's just gonna show this thing. So because linked list requires iteration, so we must have another function also to show what do we have in our linked list. Okay, let's write a define print my linked list. Okay, we'll print my linked list doing nothing. It's gonna be accessing the self, the object. Okay, now we have to check for each and every condition. Okay, what is an algorithm? You have to write each and every possible possibility. Okay, if you don't write this condition, that if self dot head is none, if self dot head is none, what's going to happen if head is none? Right, if head is none, you cannot move on. You have to say something, right? If head is none, I might just say return, right? I can say return 0, right? And then else, if that's not the case, else, if that's not the case, what do I do? Again, we have the linked list. We need to print A, B, C, right? We have to have a pointer here, print it, pointer here, print it, pointer here, print it. Till when will we print? When the pointer is none, right? So I have to have a temp is equal to self.head, which gives me the start, right? What I'm gonna do is I'm gonna say what? When the temp is not none, okay? If the temp is not none, this one is not none means it's not empty, right? I will say while temp is not none, right? While temp is not none, what I'm gonna do? I'm gonna say then print its data. Give me temp dot data. Okay, print temp dot data. Okay, now if when you print the data, when you printed the data, then I want you to move this pointer to B. Then what's gonna happen? Temp will be equal to temp dot next, right? Because temp is here, I want it to be here. Look at my mouse. Temp is here, I want it to be at B. So the B is for A is temp dot next, because this is temp. What is B for this my mouse pointer? The temp, it's temp dot next. That's what I'm saying. And then once it fails, I want you to say print linked list printing is done, right? Okay, now what can we do here? Now I cannot see it. If I say print linked list, nothing comes up. It's just the linked list class, right? Oh, I did a problem. My linked list. When I do this, boom, it's nothing, right? So I have to say my linked list dot, which function we have? Print my linked list, right? And boom, you have the linked list, right? So we have 1, 2, 3. Okay, let's see if self.head is none. If self.head is none, then I might just say print linked list is empty. Let's see. Okay, and then if temp else temp is equal to self.head, right? And then while temp is not none, this is true, print temp.data, and then temp is equal to temp.next, and that's it. Print temp.data and is equal to this. Let's see, 3, 2, 1. So we added front one. Yeah, our list is basically this because we are every time adding to the front. That's why I was confused and checking again, because our list is like this right now: 3, 2, and 1. Now you see, I might add at the back. Okay, this is like this. Copy. I might add at the back 4. I might add at back 4. Let's copy this, paste it here, add at back 5, right? And we're gonna print. So our linked list is gonna look like we're adding 4 and 5. So this is gonna add to 4, this is gonna add to 5, right? Let's print it. You see, 3, 2, 1, 4, 5. Linked list printing is done, right? This is the formatting is a normal issue. You can do it. I'm gonna show you someday about formatting. So guys, this is our linked list. This is the node that we have. This is the class for the node. This is the object. This is the class for linked list. This is the object, and these are the methods and functions of those objects: added front, added back, and print linked list. In the next video, probably or I might leave those sections, and you can write a function for think about how to add to a specific index, and think about how to find a value, how to delete a value. Those things you can do it by yourself, but most importantly, pick a paper, think about it, draw it, and I'm also gonna make another paper session probably about this. But yeah, that's it. Thank you so much, and we're gonna talk again and see another video in the next video that I will record. So thank you so much. Bye bye.